Assalamualaikum. So this one was Razali and today the topic we are going to talk about is UART. This is the assignment which we have got in the digital system design in Restaurant. So in UART what we learned today is what is UART, working principle of UART, UART transmission and UART receiver. What is UART? UART stands for Universal Asynchronous Receiver Transmitter. It is a device. From this we can send parallel data through serial line, and the data which we transfer is transmitted as where it is used. So UART is frequently used in conjunction with the Electronic Industries Alliance, which specifies the electrical, mechanical, functional, and procedural characteristics of two data communication equipment. Popularity of UART is, however, decreasing, as because of SPI between components, but it is still important for lower speed, low throughput applications. Now coming towards working, as I said that UART is UART stands for Universal Asynchronous Receiver Transmitter, as it is asynchronous, though the transmitter and receiver do not share a common clock. The transmitter and receiver therefore must transmit at the same speed or use the same frame or structure for parameters. So UART commonly it depends on these baud rates which are written like 4800, 9600, 19200, 57600, and 115,200. These are the common baud rates in which UART do communication. Now, what is the UART format, frame format? How UART transmit the data? So in UART we have basically three types of bits: start bit, data bits, and parity bit. When there is high voltage, commonly when we talk about other circuits, then we know about the terms like high voltage, low voltage. But coming into UART, we have we use mark for high voltage and space for low voltage. In the ideal state, it also has three states: one idle state, second start, and for third stop state. So in the idle state, the line is held high always. Now coming towards what are start and stop bits. The start bit indicates data is coming. It means the transition from either high to low, and whereas the stop bit indicates the data is complete, and it depicts that the data is to return to idle, or second option is to stop it. Now coming towards the data bits. What are the data bits in the UART system? So in UART the data length is commonly between 5 to 9 bits, usually 7 or 8. Data is typically sent with the least significant bit. For example, if you want to send S digit through UART, S word. So S letter in ASCII, the value of S in ASCII is 100011. If we write in LSB order, like least significant order, so we will have these last two bits 1 in the start, and we write in reverse order like 1100101 in LSB order, which is known as. Now coming, what is parity bit? Parity bit, as we all know, that parity is used for error detection. Even parity refers to number of ones must be even, and odd parity refers to number of ones must be odd. It can detect a single flip bit only. For example, if you want to send S or S letter, so it has 4 ones. Now, if our parity bit is even parity, then it will detect for the number of ones if number of ones are even or not. So in this word, in this S letter, we can see that number of ones are 4 that are even. So it will generate the parity bit as 0 because the number of ones are already in even. But if it is odd parity, then the parity bit will be 1, so that the number of ones will become odd, just like in the picture below. Here is the parity bit. Now there is even parity, that is 0, and the odd parity. Now, what is UART transmitter? UART transmitter is a special shift register that loads data in parallel and then shift it out bit by bit at a specific rate. UART transmitter usually shares the baud rate generator of the UART receiver and uses an internal counter to keep track of the number of. This is a Verilog code which initializes the transmitter, write enable pin, clock, clock enable, transmitter and transmitter busy. So we can see the parameter which I have told at the start, that the parameter we use in UART are basically state idle, state start, state data, and state stop. So when the data will be 1 1, it will be stop, and when in idle state it will be 0 0. When start bit, the data will be 0 1, and in state data it will be 1 0. So this is the diagram that how we are the transmission of data towards your receiver. Your receiver, it shoots in data bit by bit and then reassembles the data. Receiver can retrieve the data bits only by using the predetermined parameters because of no clock information. In UART we have no clock information. That's why the receiver can retrieve only the data bits that are predetermined. So to obtain the data we use oversampling. Now, what is oversampling? Oversampling basically performs a function of a clock signal. It does so by utilizing the sampling text to estimate the middle point of each frame. So this is a Verilog code for receiver in which we are initializing its parameters and its input and output variables. And below the diagram of receiver. Now, concluding our presentation is that UART is a universal asynchronous receiver transmitter. It is simple two-wire protocol for exchanging serial data, no shared clock. Baud rate must be configured the same on both sides. Start stop bits use the frame user data optional parity bit for detecting single bit errors. Widely used serial data protocol but slowly being replaced by SPI, I2C, USB, and